Now that we have created subblocks and regular blocks and loaded some wireframes and visualized the flagging, what we can do is to see how we can export the data that we just created. So as always, the first thing we do is to define some output folder. I'm gonna save on the same output folder that we had before, but just in case, we do always make sure the output folder exists by creating it. So this cell will make sure that the folder exists, and we can move into exporting the block model. So the first one is exporting the block model to CSV. The block model grid contains the columns domains, but that's all. If I do a to CSV here, it will just export the domains, and you won't be able to load this block model in other software because there's no information of coordinates and centroids of the blocks in this file. So in order to actually get the coordinates, what we can do is to do a 2-point data. So this will convert the block model into points in space, and the coordinates here are the centroids of each block. So if I do a 2-point data, then this becomes a point data. Then I can do a to CSV and make sure I save on my output folder. So this will save the file to a CSV. Because the index is not useful to us, we usually do index equals false. So this will save the block model to the output folder. So if I check the output folder, I now have this block model.csv with the 2 columns that I had in this block model. And for the subblocks, it's much of the same. Again, if I do subgrid and head, we only have the domains inside. But if I do a 2-point data, it adds the coordinates. And in the case of subblocks, it's also important to have the block size for each location as well, so that you can load that in another software or even load it back into RMSP. The rest is the same, so I can just do a to CSV, and this is going to be our subgrid.csv. And same thing, we can remove the indexes since we're not going to use that when loading the block model. So this is how you export regular grids and subblocks to CSV format that can be loaded in any other software. Specifically for block models, we have also the datamine format. So in order to save that, we just have to do grid to dm blocks and then specify the location, and that's going to be block model.dm, and this will save the block model into a datamine format. The nice thing about saving into a datamine format is because if you load it back, say rmsp.griddata.fromDM and read it back, the type of the loaded data is already gonna be grid data. So that means you'll have access to every property of the grid. So you do not need to convert it to a grid. It's gonna already be a grid. Because we're gonna have one more notebook that's gonna use some of the information we just created on this notebook, we are gonna save those into pickles to make it easy to load in the next notebooks. rmsp.toPickle DOM solids and that's going to be dom solids dot pickle. So here I'm just exporting the domain solids that we loaded into this dictionary into a pickle, so I can use that in the next notebook. Since we flagged the composites, what we want to do as well is to export the flagged composites so that we can load in the next notebook, and the composites is already gonna be flagged. And lastly, we can also export the topo to a pickle file so we can load into the next notebook.